So for this example on how generics are made, we are going to make a box class, right? It's very boring. Box. And what box is going to do is that for right now, it's going to hold something. It's just literally a box to put something in. It holds an object. I'm not even going to bother making it private. I'm just going to make it public, right? And then new how generics work, right? I'm just going to go ahead and put that there, right? We'll put a public static void main in there, right? It's a very basic class. You can't really do anything with it, but it's going to illustrate the purposes of, it's going to illustrate how generics work, right? And we can put anything we want in this box. Box B is equal to a new box, right? What am I going to put into the box? B.O is equal to the string hello, maybe. And maybe now it's equal to the equal to 5, right? Right, we can put anything we want into there. Okay? We could even put a new box in there if we wanted to. Boxes and boxes, right? You can pack boxes and boxes. You've done that before. Okay? But say you wanted this box to hold a specific type. You wanted it to be a box that held an integer, a box that held a box that could only hold an integer, a box that could only hold a string. Right now it could hold anything, but suppose you wanted to hold something else, right? So with this, we'll use a generic. And the typical way we use a generic is by adding this less than and then a e and then a greater than, this to the right next to the class. And that indicates that this class has a generic type in it. Or rather, each instance of the class has a generic type in it. We'll learn also about generic methods as part of the assignment for next week after the Fox and Rabbit program. You'll be learning how to make generic methods, but for right now, generic static methods. But right now, and those are really the two contexts that you'll see that we'll use generics a lot in this class. But this is a box that will hold a specific type E. And rather than putting object here, I'm going to put E element, right? So now we'll go back to here, and here's what happens. I'll put I want this box to hold only strings. So box B can only hold strings. Now this is what effectively happens here from a understanding how this works standpoint. Because I created a box and I put a string here, okay? When I create this instance B, effectively what goes on is that Java goes in and says, there's a string here. I'm going to go ahead and every single capital E that I see, capital E by itself, right? So if my element was spelled like this, it wouldn't go ahead and it would ignore that. It's looking at this as a whole thing of itself. So every time I see a type that's represented by an E, I'm going to replace that E with a string, right? So I'm going to go ahead and generate getters and setters. So, well, actually I'll do that after, right? So it's a box of strings, and notice B dot element. I can put in hello, but I can't put in 5 because because what happened is that this E got replaced by a string, so it can only be filled by strings. Now, why was it with a list that if I didn't have anything, I could put anything in there? Well, if you leave it off, then Java has no idea what you want. It has no idea what I want to put in the box, so it just so effectively what it does, you can think of it this way. The truth is always way more complicated, but for understanding how it works, you can effectively think, I didn't declare anything, so it doesn't know what to do, so it's going to replace all the E's with objects because I can store anything in an object. So how do getters and setters work if you don't know the type, right? So it's going to work like this. To create a getter, well, a getter, right, to get the element, public get element, we need to figure out what the return type is. And, well, what is the type for E? So type for element, well, it's E. So we're going to put E here, as silly as that sounds. Okay, and so now when I go back to here, to generics work, I can do b.getElement, and see over here, it's going to return a string. Right? And if I try putting an int over here, it's not going to work because it's returning a string. Right? All instances of E in this instance of box have been replaced by a string. Have been replaced by this word string. Same with a setter. A setter would look like this. Public public void set element takes in a type E element, and we're going to say this box's element is equal to element over here. Boom. So that type E, again, that type E is going to, if I put string here, it's going to be replaced by the string. If I put scanner here for some reason, it's going to be replaced by scanner, and only a scanner can be stored in this box, right? Notice that basically that now if I look at b.element, it replaces, it's going to be returning b.element is going to give me back a scanner. Okay, it's also important to know if I do box string, right, other box, new box string, that this guy is going, this one only holds scanners, but B only holds scanners, whereas other box only holds strings, right? So this instance, all of its E's were replaced by scanner, and this instances, all of its instances were replaced by strings. Okay? So what limitations do you have? Actually, this is very powerful. So powerful, I can't really explain the capabilities right now. Like, you can use the extends keyword here and the super keyword here, and it gets really, it's really powerful as to what you can put here. But effectively, you can put any kind of object here in place of a generic, right? So let's go back to using our list example. I can create a list of strings, I could create a list of scanners, I could create a list of lists if I wanted to. Okay? The one thing you cannot do, though, is you cannot use, well, you can put any object there. So that excludes what? It excludes primitives. So I cannot make a list of ints. List of ints, list of nums is equal to new array list. That's not going to work. Notice over here it says it cannot be of type you can't put a primitive there. Okay, well, that seems kind of disappointing and counterintuitive. So what do we put there? Well, you notice instead of saying int, I've been saying integer. So now we're going to learn about wrapper classes. This one will be, and this upcoming video will be very short.